Hi everyone, welcome to my video on GCSE Mathematics. We're looking at the higher tier Edexcel calculator paper. So we're going to work through the whole thing. There's the formula page, and we're going to see if we can get full marks, which would be good. Question 1. The point A has coordinates 2, 3. The point B has coordinates 6, 8. M is the midpoint of the line. Okay, so M is in the middle somewhere, exactly in the middle of the line AB. Find the coordinates of M. So basically, you've got a line that goes from A to B. You want to find the middle of it. Now, A goes across 2 and up 3, and B goes across 6 and up 8. So the question is basically saying, what's halfway between 2 and 6? What's halfway between 3 and 8? Okay, and the x value goes first, and then the y value. So, halfway between 2 and 6 is going to be 4. A trick, if you don't know how to do this, is add the two numbers together and divide by 2. Okay, and that gives you the middle. So, our x coordinate is 4. You might count into the middle between 3 and 8, but let's use our new trick, see if it works. 3 plus 8 is 11. You've got your calculator, half of 11 is 5.5. You're basically finding the average of the two numbers. Okay, that's the middle of them. So that's the answer to the first question. Clear that off. Question 2. The table shows average temperature on each of 7 days and the number of units of gas used to heat a house on these days. And let's just look ahead to see what we're going to answer. Complete the scatter graph, show your information. And part B, describe the relationship between average temperature and the units of gas moved. Part C, estimate the temperature on a day where 12 units of gas are used. Okay, so units of gas is going up the side. Okay, and average temperature is going along the bottom here. So, 0, 20, 0 average temperature, and 20 units of gas used has already been done for you. Okay, 1, 16. You can use these to check that you're going to do it right when you come to do it. 3, 18, 9, 10, 9, 10, 10, 6, 10, 6, 12, 6, okay, so 12 across, 6 up is going to go to here, and 13, 2. 13 is halfway between 12 and 14, and 2 up. Okay, so that is your points. Now, can you see that the points are going down as a trend? And what we're going to do is we're going to try and draw a line of best fit that goes through the middle of the points. Okay, you would use your ruler for this. That's my line of best fit. There's no one perfect answer for this. And part B, we've done part A. Part B wanted us to describe the relationship. Okay, so as the average temperature increases, the units of gas used goes down. Okay, units of gas is going down, average temperature is going across, down, across, down. Can you see? We always read from left to right on these. So you would write as the average temperature of what we're talking about, the flat, the house, yeah. As the average temperature of a house increases, so think about it being hot in summer, okay, you're not going to have the heating on as much. The units of gas used decreases, and that will get you the mark, okay? Used decreases. Right, let's just scroll down to see part C, because I've forgotten the number. Estimate the average temperature on a day where 12 units of gas are used. So 12 units of gas is here. So we go across to our line of best fit. We go down, Okay, and that is 6 and 3 little squares. So we need to work out what each little square is. That's 7, so we must be going up in 0.2. 2, 4, 6, 8, 10. You see? Okay, 0.2, 0.4, 0.6, 0.8, 1. Okay, so it's 6.246, 6.6 degrees C. Estimate for the temperature. Okay, sorry that got a bit messy. It's because the question was spaced across 2 pages. Okay, x equals 0.7. Work out the value of x plus 1 squared over 2x. So all you're going to do is where you've got x, you're going to substitute 0.7. You're going to put 0.7 instead. What goes between a number and a letter? A little multiply. So what we're actually trying to work out is 0.7 plus 1, aka 1.7, divided by 2 times 0.7, aka 1.4. But what I'm going to do is just type this. It is a calculator paper, so you don't need to do stuff in your head. Show that onto your screen using this button. Get it exactly the same, okay? And using the little x squared button. So brackets 0.7 plus 1, close brackets, little x button squared, okay, and then on the bottom 2 times 0.7. If you've got the Casio FX83 GT like me, okay, then it will give you as a fraction for your answer, and you need to press the SD button to get it as a decimal. Write down all the figures on your screen. 2.06428571. 2 marks. Okay, let's clear that ink. Question 4. Here is a circle. The diameter of the circle is 9. So straight away I'm thinking, okay, all the way across is 9. That means that halfway across is half of 9, 4.5. If you're not sure about that, use your calculator. It's a calculator paper. Work out the circumference of this circle. So I didn't actually need this 4.5, but you know what I'm like, trying to think about everything we might possibly need. Circumference of a circle is pi d, okay, where d is the diameter. You might have been taught 2 pi r. That is only because 2 times the radius is the diameter, so they're the same formula, okay. If you've got 2 times 4.5, you're going to get 9 anyway. So I think this one's a bit easier, but it just does mean you have to remember it. So pi times the diameter, 9. Type it in your calculator. 9 times by pi, shift pi, and SD button. 3 significant figures. Let me write down above what my calculator says, because rounding is very, very important. Okay, now we've got to round to 3 significant figures, which means we want the first 3 numbers, okay, first 3 non-zero numbers. So we're going to get 28 point, look at the 7, that's going to round up. 28.3. Please don't make mistakes in your rounding on the paper. Question 5. Describe the single transformation that takes A to B. Okay, what takes A to this shape? Now can you see that it's the exact same shape, not spun around or anything like that? Okay, so that is very important, that you can just move it. When you just move it, it's a translation. Now okay, you might move stuff diagonal, but what maths does is it says forget diagonal. Any diagonal can be done by going across and up, or across and down. Okay, so we want to know how many down, how many across. More specifically, how many across, how many up, like this, and this is actually called a vector. So let's count how many across. 1, 2, 3, 4, 5. Okay, so it's 5 across, and that's positive to the right, so that's just a positive number. Let's count how many down. 1, 2, 3. But it's gone down, so it's a -3. If you didn't have the ability to move your shape on your paper, just do this. 1, 2, 3, 4, 5. 1, 2, 3. You see, and that's down. Now, because it's a movement, you have to write the word translate, okay, and then give the instructions 5 minus 3. You could just write to the right 5 and down 3, but I just think the vector form is much nicer. Sue's driving home from her friend's house. Sue drives 10 miles from her friend's house to the motorway. I like my diagrams. Let's get a picture of a motorway. So 10 miles from her friend's house to the motorway. Okay, this is her friend's. 240 miles on the motorway. Poor Sue. It's a long way to go. Okay, 240 miles. 240 miles. 5 miles from the motorway to her home. Okay, 5 miles. And this is home. She takes 20 minutes to drive from her friend's house to the motorway. So she's done 10 miles in 20 minutes. She drives at an average speed of 60 miles per hour here on the motorway. She takes 25 minutes to drive from a motorway to her home. So if you think about it, it's taken her longer to drive back to her house, I know how this feels, believe me, in rush hour traffic, than it did to drive 10 miles from a friend's to the motorway. But anyway, it's not what it's asking for. Sue stops for a 30-minute rest on her drive home. To be honest, I don't blame her. Okay, so somewhere here, 30-min rest. Okay, she leaves her friend's house at 9 a.m. What time does she get home? So it looks like it's been some kind of a visit that Sue's had, maybe for a weekend or something, or maybe a night, I don't know. Anyway, 9 o'clock, and she travels for 20 minutes. Okay, so let's go over next journey, add on 20 minutes. Okay, we can tick that one off, tick that one off. We're on the motorway now. 60 miles per hour for 240 miles. 60 miles per hour means in 1 hour she's done 60 miles. That's what it means. Okay. Now that means 120 miles is 2 hours. That means all I'm doing is adding 60 each time. 180 miles is 3 hours. And that means 240 miles, which is what we want, is 4 hours. Okay, so let's add on 4 hours. 13, we'll do it 24 hours for now. 24-hour clock. 13:20, and you can convert. 12 o'clock is midday, then you've got an extra 1, so it's 1:20 p.m. Now don't forget her break. She had a break for 30 min. Okay, so we've done a little drive, but we need to add the break on as well. So that's going to be 1 hour 50. Okay. The last little bit, she's doing 5 miles to get home. Well, we don't care that it was 5 miles. We just care that it was 25. No one told me I wrote miles instead of minutes, so let's just change that. Hopefully I said the right thing. 25 minutes, let's add it on. Okay, so let's add on 25 to 150. If you add on 10 minutes, that gives you to 2 o'clock. And you've got 15 more minutes to add. Okay, so that's your final answer. 2:15 in the afternoon. That was for how many marks? 3 marks. Okay. You might have been able to do it a bit quicker with your calculator, but there you go. I like to see what's going on personally. Question 7 is a starred question, so it needs some explaining. PRS, let's highlight that. P RS, let me guess, straight line, and they're parallel. Okay, so this line is parallel to this line. As you can see by these arrows, that means that they are always the same distance apart. QRWZ, which is this line, is a straight line. We can see that, okay? Work out the value of x. So the value of x is this angle that we want to find. Give reasons for your answer. Okay, can you see this Z shape? You need to look out for Z shapes in your exam, okay, for angles. It could be any way around. Can you see that this angle looks like this angle? That's because they're the same. Okay, so let's explain that. So this angle that we've just talked about is angle RWY. So angle RWY equals angle PRW. And what it's called when you've got the Z angles is alternate angles. Okay, so that's our reason. The next thing that we've got is we've got angles on a straight line. So x equals 180 minus 126, which equals 54 degrees. Okay, because angles on a straight line add to 180 degrees. Okay, so we've given our two reasons and we've got our answer of 54 degrees. Moving on, that's 3 marks again. Lorna carries out a survey about the number of times customers go to a shop. She asks at random 100 customers how many times they went to a shop last week. The table shows her results. One of the 100 customers is chosen at random. What is the probability that the customer went to a shop 5 or more times? Okay, so 5 times is 13, 6 times is 11, more than 6 is 5. So if we add up all these, you can use your calculator if you want, or do it in your head. So 18 plus 11, 29. So it's 29 people over 5 visits. Okay? Probability, well, there's 100 customers that have been asked, so it's out of 100. And how many people are we interested in? 29 out of 100. You can leave it as a fraction, or 29%, 0.29, whatever you fancy. Right, last month the shop had a total of 1,500 customers. Work out an estimate for the number of customers who went to shop exactly 2 times last month. So let's think about the probability that a randomly selected customer out of 100 went 2 times, which is here. So 2 times it was 13 out of 100. Okay, that's the probability estimate that they went 2 times. If we times our probability by how many customers we've got, that actually gives you this fraction of these people, okay, which will actually estimate how many you would expect. So on your calculator, type in that exact thing, 13 over 100 times by 1,500, and you get the nice answer of 195. Okay, what's part C got in store? Hopefully we can clear this ink, and I won't live to regret it. The owner of a different shop is carrying out a survey on the ages of his customers. He records the ages of the first 10 customers in his shop after 9 AM one morning. This may not be a suitable sample. Give 2 reasons why. Well, come on. 10 people out of however many customers you could have in a shop. Okay? 10 is not enough people. And if you really want to be fancy about this, for a representative sample. That means that randomly asking 10 people won't represent all people. Representative sample. Okay, let's read out what else is happening. The owner of a different shop is carrying out a survey on the ages of his customers. He records the ages of the first 10 customers in his shop after 9 AM one morning. Now, imagine a normal day for you guys, okay? What are you doing after 9 AM? Hopefully you're at school, okay? What are some of the adults that you know who are working age doing? They might be going out to work, okay? So you could say certain ages, e.g. children, will be at school after 9 on a weekday. Okay, so it's not fair. It is biased. Okay, which means it's not fair. It's not giving everyone a chance of different ages if you're only asking at a certain time. Okay, clear ink. Question 9. There are other reasons there, but we just needed to give 2. Diagram shows a trapezium. Again, can you see these arrows representing parallel lines? AD equals X. Always read, because you might have to label stuff on yourself, and do label stuff on. Okay, don't leave it blank. That diagram is for you to draw on. BC is the same length as AD. So guess what? If AD was X, BC is X. AB is twice the length of AD. Okay? So let's look at this. AB is twice this length. So it's timesing it by 2. What do you get when you times X by 2? 2X. Okay? Fine. DC is 4 centimeters longer than AB. So here's AB, here's DC. So we've got this one, 2x, and then we add on 4, because it's 4 longer. So we've labelled the whole shape for us. Okay, so that's a good thing to do. The perimeter of a trapezium, that means all the way around the edge of a shape, is 38. So when you add up this, and this, this, and this, you get 38. So let's do that in algebra. Okay? I actually do this all in one go. So I think, how many x's have I got straight away? 2 there, 2 here, so that's 4 x's. Add another one, that's 5 x's. Add another one, that's 6 x's. Okay? And then you can think about your numbers. The only number you've got is 4, and then you've counted everything. So 6x add 4 equals 38. Now we want to get x on its own. We want to solve this equation. Take away 4 to both sides. And you get 6x is 34. This is why it's a calculator paper, because we want x on its own. We're currently timesing by 6. We want to divide by 6 to undo it. Type in your calculator, 34 divided by 6. And you can leave it as 17 over 3 or 5.6 reoccurring. I prefer 17 over 3, and it is in centimeters. Do not forget your units. Okay, question 10 is some algebra. So let's get cracking on that. P cubed squared. What this actually means when you square something is this thing inside gets times by itself. Okay? So you can actually think of it like that, and you're going to be doing p cubed p times p times p, p cubed p times p times p. So you've got p times p 6 times, which is p to the power of 6. There's a shortcut that I've not shown you yet. P to the power of 3 to the power of 2, you can just do 3 times 2. But this is the reason. why it works. Okay? That's your answer, p to the power 6. Simplify. T to the power of 8 over t cubed. Again, you should know the rule that when you divide the numbers to the powers, if the base number is the same, that's the big number, then you can just take away the powers. The reason is that you've got t times by itself 8 times on the top, 2, 4, 6, 8, and 3 times on the bottom. So that's times in by t, dividing by t, times by t, divide by t, times by t, divide by t. Guess what? You've done 8, take away 3. And that's to the power of 5. Okay, again, you can just use a shortcut. I'm trying to show you what's going on a little bit more. This looks more like an A-level question, to be fair. So 2 to the power of 3 times 2 to the power of some missing number, okay, some mystery number, gives you 2 to the power of 9. When you multiply, you add the powers. So this just means that 3 adds some number gives you 9. So that means a missing number must be 6. Try it. 2 to the power of 3, 2 to the power of 6. You do 3 add 6, you get 9. Okay, so n equals 6. Clear the ink. More tricky one now. Work out the value of x. 2 times x cubed is 128. This is a calculated paper, so don't worry too much. All you need to do is get x on its own by undoing what's happened to it. It's been multiplied by 2 into the power of 3. Now, not everything is to the power of 3, so we'd first need to get rid of this times 2. Let's divide by 2 on both sides. So you get x cubed left, and you get 64. Now, if you want to get x from x cubed, you have to do the cubed root. So the opposite of x squared is the square root of x. The opposite of x cubed is the cubed root. The opposite of x to the 4 is the 4th root, etc. Okay, the one we're interested in is the opposite of x cubed. So we're going to do the cubed root, and that's the button on your calculator. Okay, it might be yellow, so you might need to press shift. We're going to do it to both sides. So type in your calculator, cubed root of 64. Make sure you press shift so you don't do the square root, and you get x is 4. That's because 4 times 4 times 4 gives you 64. 4 times 4 is 16, times 4 is 64. Okay, so x equals 4. Clear ink. Question 11. Here is a plan of Martin's driveway. Martin is going to cover his driveway with gravel. The gravel will be 6 centimeters deep. Gravel is sold in bags. Let me just get a visual representation for us. This is his drive. Let's try and make it a bit 3D, because it's going to be going up 6 centimeters. Okay? So let's think of this as a plan looking down on the driveway. So that's going to be 6 up, 11 across. Oh, it's not centimeters, it's meters for the 11, so we'll need to talk about that in a minute. Obviously, your driveway won't be won't be 11 centimeters. That would be ridiculous. Okay. Gravels are sold in bags. There are 0.4 meter cubed of gravel in each bag. Each bag of gravel costs £38. Martin gets a discount of 30%. There's lots of stuff going on here. Work out the total amount of money Martin pays for his gravel. So from our diagram, this is what we're filling with gravel. Okay? The exam has only given you the 2D version. We've made it the 3D version. If it was being really nice, it would have given you this as a question that you might have seen like this for the driveway. But it's not. It's helping you to think about it yourself. So, let's first of all work out the volume. To get the volume, we're going to do the cross-sectional area, which is going to be 11 meters times 4 meters. But before we do that, we want everything in the same units. So you can either think that you want this in meters or these two in centimeters. Now I'm going to change everything to meters because, look, we've already got the bags in meters. So let's keep our units as meters. 1 centimeter, well, 100 centimeters make 1 meter. Okay, you should all know that. If not, you need to learn it. So 1 centimeter divided by 100, 0.01 meters. So 6 times by 6 centimeters, 0.06 meters. Okay, for here. So, for the volume, 11 times by 4 times by not 6, but the same thing in meters, 0.06. Okay, 11 times 4 times 0.06, which gives you 2.64. Now look, that is meters cubed. That's the total we need. Okay. Each 0.4 is a bag. So we want to know how many bags go into 2.64. So we're going to see how many go in by dividing. So 2.64 on your calculator divided by 0.4 gives you 6.6 bags. Does that make any sense to go into a shop and say, right mate, can I have 6.6 of those please? I need it for my drive, you see. They're going to be like, what are you even on about? We're not going to cut a bag up for you. You're either going to buy 6 or 7, make your mind up. And you'll think, well, 6 won't be enough, so I'm going to have to pay a little bit extra and buy 7 bags. Okay, so 7 bags is what we need. Each bag costs 38, so 7 times by £38. 7 times by 38 gives you 266. Now it sounds like the shopkeepers felt sorry for you because you only wanted 6.6 and he's going to get himself a discount of 30%. So this could be a whole new question, but the examiners very cleverly put it all into one. Okay, I like this question, I'll be honest. So we want 30% discount. Imagine it's a question on its own from 266. So when I do this, I do it on my calculator. You could do it the non-calculator way, find 10%, find 30, take it away, blah, blah, blah. I just think if we're taking away 30% from 100, we want 70%. 70 as a decimal is 0.7, which is our multiplier, and the shortcut says your multiplier is magic because you can just times by it to get your answer. This is actually the thing that I probably use the most in my normal life of maths, okay, this multiplier thing. If you don't get it, look it up, it's very, very useful. So your final answer, with that discount applied, £186.20. That's how much Martin's got to pay. He's got his drive done, he's a happy man, okay? Gravel galore. So he will have a bit left, maybe he can put it in his back garden. The rest of the gravel, he's going to have 0.4 of a bag left. Anyway, maybe he'll keep it spare and fill it up when the gravel like spills over or something. Okay, moving on. That was 5 marks. Okay. Here's the first 5 terms of an arithmetic sequence. 4, 9, 14, 19, 24. Find in terms of n an expression for the nth term. 4, 9, 14, 19, 24. Don't worry about the word arithmetic. It just means you're adding things on each time. Let's figure out what we're adding on each time. We're adding on 5. It works every time. Okay, you could keep going. 29, 34, etc. Okay, So that means because we're adding on 5 each time, we can put 5n in our formula. Now the trick says that if you hop back to the next one, the one that would have come before 4, so we want to take away 5 to hop back, you get -1. And that's your answer, 5n minus 1. That means whatever term you want, whatever number in the sequence you're up to, the first, second, third, fourth, fifth, this formula will find it out for you. So try it out. The first number, 5 times 1, take 1, 4. The next number, 5 times 2, 10, take 1, 9. 5 times 3, take 1, 14. You get it? It's a good trick, isn't it? Here are the first 5 terms of a different sequence. 2, 2, 0, -4, -10. An expression for the nth term of this one. Look at that complicated formula. Ours was much nicer. Write down in terms of n an expression for the nth term of the sequence whose first terms are as shown below. Look at this. Can you see a pattern of how to get from what we know to the new one? We can cheat. We can start with this formula, and if we times by 2, we get the new one. Okay? Times 2, times 2, times 2, times 2. So we're going to take our old formula here, okay, and we're going to times the whole thing by 2. So we can put 2 times it. If you want to simplify, you can, but you don't have to. Okay? We can simplify by timesing in, just to show off that we're good at algebra as well. Okay, so 6n minus n squared, or this would still get you the mark. It's only 1 mark. Clear ink. Okay, moving on. Question 13. Y is an integer, which means it's a whole number. Here's your number line with 0 in the middle, 1, 2, etc. Okay, and here is your going backwards, -1, -2, -3, -4, -5, -6, etc. Okay, now y is between 0 and -5. So it's between here. However, this equals thing, can you see that we use our normal signs? If you add an extra line on, you're making an equal sign. Can you see that? If you make an equal sign, that means that you include the number as well. So we want to include 0. Okay? Obviously we want -1, we want -2, we want -3, we want -4. Do we want -5? No, because there's no equals with it. Okay? It's just the sign on its own. So we don't want -5. That's our answer for 2 marks. They're all the whole numbers between -5 and 0, not including -5, but including 0. Okay, next part. Solve this. I would advise that you cheat here. This is what we had. I would say, pretend that's an equal sign, and let's solve this, because we should know how to do these. We multiply out here, and we get 6x minus 12, 15 stays the same. We add 12 to both sides. Our aim is to get x on its own, so 6x is 27. Now we think we want x on its own, we've got 6 times it, divide by 6. We're glad it's a calculator paper, so we can just type in our calculator, 27 divided by 6, and get 9 over 2, or 4.5. Now remember, you cheated. Don't write that as your final answer. They're going to know you cheated then. It's not proper cheating, it's just a trick. This was the sign you had, not that, so you need to change all of them. See if you can disguise your working out. Pretend that you wrote that all along. You knew exactly what you were talking about. Okay? So that is your final answer, that x is greater than 4.5. If you try that out in your equation, it's going to work. Anything greater than 4.5 will give you an answer for the left-hand side of something greater than 15. Okay. Question 14. Ali is planning a party. He wants to buy some cakes and some sausage rolls. The cakes are sold in boxes. There are 12 cakes in each box. Each box of cakes costs £2.50. I usually highlight, do apologise, 12 cakes, sold in boxes, done. Sausage rolls are sold in packs. 8 sausage rolls in each pack. Each pack costs £1.20. Ali wants to buy more than 60 cakes and more than 60 sausage rolls. He wants to buy exactly the same number, wow, high demands, of cakes as sausage rolls. What's the least amount of money Ali will have to pay? So, let's think for cakes. Let's think for sausage rolls. The cakes are coming in packs of 12. Sausage roll, packs of 8. So this row can be 1, this can be 2, 3, etc. Okay, so for the cakes, let's try 2 packs. So we're going to get 24. Just add 12 each time. If you're not confident in your head, use your calculator. I'm just literally adding 12. 48, 60, 72, 84, 96, 108, 120. Let's do the rolls, see how we get on there. 8, 16, just add 8 each time, okay, for however many packs you want. 24, this is your 8 times table, by the way. 32, 40, 48, 56, 64, 72, 80. Did anyone spot anything when I just wrote 72? It's a repeat look. Okay, so that means that we want 1, 2, 3, 4, 5, 6 packs of cakes. And let's see how many sausage rolls. 1, 2, 3, 4, 5, 6, 7, 8, 9 packs of sausage rolls. Okay. So let's work out the cost now. The packs of cakes are going to be £2.50 each. They're actually boxes, but whatever. 6 times £2.50. Do it on your calculator if you want. £15. This one, 9 packs, and how much are they each? £1.20. 9 times £1.20 is going to be £10.80. Your total cost is £15 plus £10.80. Do a big add, okay? That's going to be £25.80 is the total cost. Let's check we've answered this. 60 cakes, 60 sausage rolls, exactly the same amount of each. Least number, 72. Job done. Okay, clear the ink. Question 15. Diagram shows positions of 3 turbines A, B and C. A is 6 kilometers due north on turbine B. C is 4.5 kilometers due west of turbine B. It's just all shown in the diagram anyway. Calculate the distance AC. So label on what you want to find, probably call it X. Can you spot the triangle here? Okay, if not, draw it separately. Here you've got 4.5, here you've got 6, here you've got X. I've done a Pythagoras video for you to check out. You're going to do square it, square root, or you might know the formula that 4.5 squared plus 6 squared is X squared. I don't know how you've learnt it. I teach square it, add square root. Okay, so 4.5 squared, add 6 squared. Let's do it on our calculators. Both methods do the same thing. You get 56.25. Okay, now we've done square, square, we've done add. We want to square root, which is this button on your calculator. Okay, so you do that. The square root of your answer, square root and will work, and you get 7.5. That gets you 3 marks. Okay, clear ink. Calculate the bearing. Okay, fair enough. Probably shouldn't have got rid of that. What do you call it? Triangle. Okay, because we need it again. So 4.56. And we want the bearing of C from A. C, B, A. No offence there. Okay, so bearing of C from A. So we're going from A to C. Bearings, you always start from north and you go around this way. So the actual final answer we want is this whole angle here. Okay, C from A. But let's do this one step at a time. Let's first of all find this angle. Let's call this, if you already used Y, let's use X, we'll use Y. Okay, let's label up our triangle. This is a Sohcahtoa question. I've also done a video on Sohcahtoa for you to check out if you're not sure. So you do opposite the angle is 4.5. You do the longest one, which is H, and you do adjacent here, which is next to the angle. You can choose which one you want. You could literally use any because we knew this as well was 7.5, I think. But I'm just going to use what was in the question, just in case anything went wrong before, and just because the numbers are there. So 4.56. O and A. We've got O, A, O, A. That means that we want tan. So tan of our angle, whatever you call it, we've called it Y, is the opposite, which is 4.5, over the adjacent, which is 6. Now to get Y on its own out of tan, this is tan of something, not multiplied, you have to do the opposite of tan. So tan, the opposite is tan to minus 1, which is inverse tan. Okay, they're opposites. So let's do tan to minus 1 of both sides. That gets rid of tan of something because it undoes it. 4.506. Okay, type it in your calculator. Tan to minus 1 fraction 4.5 over 6, and you're going to get, in degrees this is, Y equals 36.86989765. Remember, that's not the question finished because we want the whole bearing. This around a straight line, half a turn, is 180 degrees, so we've got to do 180 degrees plus 36.869, etc. Okay, and you can do it on your calculator if you want. We want it to the nearest degree, so it gives 216.869, etc. Nearest degree, this is what we want. The 8 is going to round up to 217 degrees as the bearing. Okay, some quite tricky questions on here, but there you go. We've figured it out. That's what we're trying to do. 4 marks. Question 16. I'm not a big fan of standard form personally, but it's a question, so let's do it. Work out the value of that. Give your answer in standard form. I know how to do this on a non-calculator. Let's just try and type that into our calculator and see what we get. 7.5 times 10 to the power of 4. You can use the little X with a box button on your calculator to get to the power of 4. Times by 2.5 times 10 to the power of 3 equals, so on your calculator it gives 1875, 1, 2, 3, 4, 5 zeros. Now, I'm pretty sure there's a way on your calculator to get this done, but just in case you've got different things, let me show you how to now change this into standard form. Okay, so to get standard form, it means you've got a number times 10 to another number here, let's call it n and m. Now the special thing about n is that it's got to be between 1 and 10, okay, less than 10, greater than 1. So the number that we can pick from these digits has to be 1.875, keeping the digits in the same order, but getting it between 1 and 10, 1.875. Now, what if you had 1.875, how many times would you have to times it by 10? 1, 2, 3, 4, 5, 6, 7, 8. So it's times 10 to the 8. That's your answer. I think that's a weird question, personally. Lots of different ways to explain it. I've tried a slightly different approach there. I hope it made a bit of sense. Question 17. Two similar shapes, quadrilaterals, mathematically similar. That means that one is an enlargement of the other. Okay, they're in the same proportions. And all the angles are the same. That's just saying that these are the same, these are the same. When you enlarge something, the angles don't change. Lost my colour scheme here. These are the same. These are the same. Okay. Work out the length of LP. So the missing length LP is here. And can you see it relates to this old 5? So you need to know how much bigger is this similar shape. You've gone from 6 to 9. And we're timesing. We're not adding, because adding doesn't work. It'll change the shape if you add the same number to each length. Okay, unless all the lengths were the same. So you have to times by a scale factor. 6 to 9, you could do 9 divided by 6 to see what it's going to say for you. But it tells you 1.5, what you've times by is 1.5. So you want to do 5 times by 1.5 to get the new answer. So 1.5 lots of 5 will give you 7.5 centimeters. Part B, work out the length of BC. So BC is here. Okay. And we know that this one is 12. So, going two different ways. When we go this way, we times by 1.5. When we go this way, we do the opposite. We can divide by 1.5. Okay? There's a different way to think of this, which is how I used to do it, which is to think to times by 1.5, you can divide by 2 times 3. And the opposite going this way, you'd be doing times by 2, divide by 3. Same thing, this is probably quicker with a calculator. So you're on 12, you want to divide by 1.5, so 12 divided by 1.5 gives you 8. Okay? 8 centimeters. And you would hope it would go smaller because this shape is smaller. Lots of lines going on there, but that's the question done. Question 18. Katie invests 200 quid in a saving account for 2 years. The account pays compound interest. That means that each year you get interest on the total amount in your bank, including the interest that you've already received. Okay. So, work out the total amount of money in Katie's account after 2 years. For the first year, she's going to get 3.3%. You start with 100%. You add on 3.3%. That means you want to find 103.3%. Remember the trick I told you, a useful trick of multipliers? As a decimal, 100% is one whole. So this is 1.033. You can just divide by 100. It's a short way to change percent to decimal. So that is our multiplier for the first year. Okay. So let's start with our original amount. Original amount was 200 times by our magic multiplier. Okay, 200 times by 1.033, and you get 206.6, £206.60 basically. That's like your new amount. Now, your next multiplier is to add 1.5. That percent, that gives you to 101.5% as a decimal. 1.015 is your multiplier. Okay, so times the answer you had on your calculator screen by this multiplier, and you get £209. It says 209.699. Round it to 70, unless your bank is going to be really mean and round down for you. Okay, that's because the 9 rounds up and then rounds up again. Katie travels to work by train. The cost of a weekly train ticket increases by 12.5% to £225. Katie's weekly pay increases by 5% to £535.50. Compare the increase in the amount of money Katie has to pay for a weekly train ticket with the increase of her weekly pay. What a tricky question. Cost of her weekly train ticket increases by 12.5% to 225. Okay? Increase. So this is about the ticket. Weekly pay increases by 5%. And the amount we get to is £535.50. And here we get to £225. What was it? Is that all the information we're given? Compare the increase of in the amount of money Katie has to pay. Okay, so it's gone up by 12.5% to £225. So this is now 100% added on to 12.5. So that's how much percent we've got. Here we started with 100%. We've added on 5%, so this is 105%. In both cases, we're going to want to work out what we had originally. So let's do the easier one first, which is the easier number. If you've got 105% and you want to know 1%, okay, you can divide by 105. So 1% equals, on your calculator, £535.50 divided by 105, which gives you £5.15 okay, so 100% times by 100 is going to be 510 quid. So the original pay was 510. Okay, what we could have done at this point is think we only want the increase. Do we care about what you started with? Not really. Let's do a shortcut. Go straight to 5% by timesing by 5. 5.1 times 5 is £25.50, which is the increase for the pay. Okay, let's do the same thing for the ticket, but with more complicated numbers. If we want 1%, and we've got 112.5, we're going to divide by 112.5. So on your calculator, 225 divided by 112.5 gives you 2. Well, nice number. Okay, 1% is £2. We want to know how much it's increased by, which is 12.5%. So times by 12.5 times by 12.5, and you get 25 quid. Okay, so let's explain what's happened, because it is a starred question after all. Okay, so pay has increased by £25.50. Ticket by £25. So her pay increase will cover the extra cost of the ticket, of the tick, with 50p to spare. I wonder what she's going to buy with her extra 50p. Maybe a couple of flint bars, I don't know. Clearing. Okay, question 19. Here's a cuboid drawn on a 3D grid. So as well as X and Y, we now come out of the page, if you imagine that. P is the vertex of the cuboid, okay, which just is a posh word for corner. T divides the line OP, so let's think about the line OP. It goes from O to P. Okay, there's O, there's P. In the ratio 1 to 2. So that is a line, so to split it in the ratio of 1 to 2, we need 3 parts. Okay, and then it's 1 to 2. So you might have seen people just adding these numbers up. We need 3 parts. So if we split that up, 1, 2, 3, T divides OP in the ratio 1 to 2. Okay, so this is going to be T here, 1 to 2. Find the coordinates of T. So it goes 4 up, it goes 3 across, it goes 6 in the X direction. So X, Y, Z, follow your alphabet. X first is 6, so you go 6 across. And then Y is next, so you go up, you go 4 up. Then 3 is next, so you come out the page, 3. But that's all the way to P. We do not want to go all the way to P. We want to go just a third of the way along. So we can just divide everything by 3. 6 divided by 3 is 2. 4 divided by 3 is 4 over 3. 3 divided by 3 is 1. So 2, 4 over 3, 1. Okay, that's question 19 done. Clear the ink. Question 20. 25 students in class A did a science exam. 30 students in class B did the same science exam. The mean marks for 25 students in class A is 67.8. Okay, so 25 students, 67.8 average, mean. For B, mean mark for 55 students. Oh, sorry, not B. Total, 55 students. All the 55 students, 72.0. Let me guess what we want. The mean mark for students in class B. So we basically know if you add up class A and divide by 25, so add up class A, I don't know what notation to use not to confuse you. Add up class A. At A level you'll use sigma, you might have seen that before, but at the minute I'm just going to show you what we're talking about in words. We add them up, divide by 25, we get 67.8. This is a calculator paper, so we can actually do any multiplication or division we want. If we want to know what they all added up to, we can times by 25. Okay, so 67.8 times by 25 on your calculator. When you add up A, you get 1695. Okay, now we want to carry on adding up to add up everyone. So we get 1695 plus all of B added up, divided by 55, because that's how many people there are in total, and you get the answer of the average 72. So if you want to know this, it's like an equation with an unknown. You can get this on its own, think of it as maybe x, get it on its own, times it by 55, 72 times 55, 3960. Now we take away 1695 and we get all of b, or sum of b, equals 2265. If we want the average, or the mean, we have to divide by how many there are. So we have to divide by how many students in class B, which is 30. So on your calculator, divide that answer by 30, and you get 75.5 as your answer. Bit of a tricky one. Like I said, for notation, you could use the sum of A for this, but I was just explaining to you the formula in words, so hopefully you can follow clearer what's going on. Question 21, nice bit of algebra for us to do. Y minus 2, y minus 5. I hope that you can do these really confidently and you're happy when you see them, because you know you're going to be getting the 2 marks for it. So, first one we do y times y usually, y squared. Y times minus 5, we'll do y times 5, 5y, and just put the minus in front. The only difference is when we have 2 negatives, which we'll see in a minute. Minus 2 times y is going to be minus 2y. And then finally, minus 2 times minus 5. We'll just do 2 times 5 is 10, but then it's a minus times by a minus, so that's going to make a plus. Think of your 2 signs going together and going to a plus sign. Okay, so that's a plus. Now we combine the middle 2 terms if you've done it in the same order as me. Think of your number line, you're on minus 5, you take away another 2, you're on minus 7y. Okay, so that's your answer. Prove algebraically that 2n plus 1 all squared, take away 2n plus 1, is an even number. Let's think about what it means to be an even number. An even number means your 2 times table. Okay, so what's in your 2 times table? 2, 4, 6, 8, 10, etc. You can even go into your negatives for even numbers as well. And people call 0 an even number as well. But anyway, let's focus on the 2 times table first. So what we need to think about is 2 times 1 is our first one. 2 times 2, 2 times 3. So 2 times something gives us a number in the 2 times table. Okay. Now let's look at prove algebraically. We're going to apply our algebra skills to this little expression. Okay. First bit, 2 plus 1, or 2n plus 1 all squared. Well, squared means times by itself, so let's times that by itself. And then we're taking away 2n plus 1. Let's expand these double brackets at the front, like we did up at the top. Okay, so 2n times 2n, 4n squared. 2n times 1, 2n. 2n times 1, 2n. 1 times 1, 1. And now we're taking away this whole bracket here. So you need to take away the 2n, you need to take away the 1. To make this easier, you could think of this as minus 1 and times it in like a half a banana method. Okay, so minus 2n minus 1. So this minus 1 will take away this 1, so they're going to cancel out. This take 2n will cancel this 2n, so they're going to cancel out. So all we're left with is 4n squared plus 2n. Remember that we said we wanted 2 times something. Well, we can factorize out a 2 from this bracket, because 2 goes into 4, and 2 goes into 2. And then what we need in the first bit is 2n squared plus n. So it's 2 times something. So how can we show that this something is just a number? Well, it tells us that n is a positive integer. Okay, so n is a whole number. That's what positive integer means. Okay, whole positive number. So if you square it times by 2 and add it on again, you still get a whole positive number. Okay, and let's write a little bit more because it is a star question, so we do have to explain what's going on. So it's going to be 2 times positive number is even. Okay, so here we could write therefore even, and this is our reason for that. Okay, proof questions are quite nice when you know what to do with them, and they do go into a bit of A-level maths as well. Shabin has a biased coin. The probability that the coin will land on heads, instead of drawing a head, let's just put H, is 0.6. So let's write that down. Probability of getting a head is 0.6. Shabid is going to throw the coin 3 times. She says the probability that the coin will land on tails 3 times is less than 0.1. Is Shabin correct? Show all of your working. Okay. So land on tails 3 times. So the probability of getting a tail is going to be, assuming you can only get a head or a tail and it can't go on its side, it's going to have to add up to 1. Okay? Because 2 probabilities of things, the only possibilities, must add up to 1. So that's 0.4. If you want the probability of tail, 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 you do the probability of a tail times the probability of another tail times the probability of another tail. Okay, which is 0.4 times 0.4 times 0.4. On your calculator, same as 0.4 to the power of 3. And you get 0.064. And then Shabid is right, because 0.064 is less, you can do this as a math sign if you want, than 0.1. So Shabin is correct. Well done, Shabin. Very good. Clear ink. That was 3 marks. You could have done that with a tree diagram, but it would have taken longer. Explain what is meant by stratified sample. So stratified sample, let me just briefly explain to you what's going on with it. If you had in a group, say, 70 boys, 30 girls. If someone said to you, can you pick me, out of 100, can you pick me 10 boys and girls? Okay. Would you just pick 5 girls and 5 boys? Maybe you would. Okay. However, does that represent how many we had in the original group of people? There were loads of boys, not many girls, and yet you've picked the same amount of boys and girls. Is that fair? Or is it not fair? Well, stratified sample would say, no, that's not fair. Because there's 70 boys, you need to have more boys than girls. So let's go for 7 boys, and let's go for 3 girls to make it up to 10. That is stratified. Okay? So stratified, let's explain it in posh terms. stratified sample is representative of the population and in it groups appear in the same proportion. So same proportion or same ratio. What that means is, before we had 70 to 30, then we chose to have 7 to 3. They're the same, they cancel down to the same thing. Now, if you have a calculator, you can do much more tricky ones than 7 and 30 cancelling to 7 and 3. So guess what? That's what the next question is going to be. The table shows information about the ages of people living in a village. Under 21, 21 to 40, 41 to 60, over 60. So to show you how to read this, if you want to know how many people are between 21 and 40, there's 90 people. Okay? So, Mrs. Parrish carries out a survey of these people. She uses a sample size of 50 people stratified by age group. Here we stratified by gender, boys and girls. Here, age group. Work out the number of people over 60 years of age in the sample. So we want 50 in total, okay? And we want to know what our population adds up to. So let's do the sum of these, okay? Let's add them up. 72 plus 90 plus 123 plus 314 599. Thought it would have at least added up to 600. Okay, 599. Just check I've done that right. Fair enough. Your choice. Okay. Work out the number of people over 60 in the sample. So in our real data, we've got 314 out of 599 as a fraction. Okay? We want the same fraction out of 50. Okay? So 314 out of 599 of 50 as a fraction. We can do that by multiplying. So 599, 314 over 599 times by 50 on your calculator gives you 26.21035058. You cannot start cutting people up, so we need to make a decision. Are we going to go with 26 or 27? So we need to round and go for 26 people. Okay, because we round 2 down. And you need to make sure, if you were doing this for all the group, you need to make sure that all the numbers you picked added up to 50, because that's how many you want in your sample. Right, that was 2 marks. Question 24. P is inversely proportional to T. When T equals 4, P equals 12. Find the value of P when T equals 6. Last time I did one of these questions on YouTube for you, I made a mistake because I didn't reread the question after I finished, and I didn't do the final bit. So let's focus on this one to not make the same mistake again. Now I'm going to show you the proper maths way to do this. There are some shortcuts, but I think it's nice to follow this method through because this is useful in real life to see how things are related, and you can solve lots of difficult problems using proportionality. Anyway, P is inversely proportional to T. So that means that P is proportional to 1 over T. Okay? So this sign is a math sign to just say how they're related. So they're related in a relationship where one increasing makes the other increase or decrease. Okay? So that means that to get p, you can do some number times by 1 over t. So basically you can think of this sign when you make it an equation changing to this. Okay? When t is 4, p equals 12. So let's do a substitution question now. We're going to put t as 4 into here and p as 12 into here. So 12 equals, k is what we don't know yet, 1 over 4. We need to get k to find out what it is, so we need to get rid of this quarter by timesing by 4. 12 times by 4 is 48, so that's k. Therefore, our whole equation, going back to here, to get p, you do this number, which is 48, times by 1 over t. Okay. And then let's not forget the last bit. Find the value of p when t equals 6. So to get p, you do 48 times 1 over whatever t is, in this case 6. So 48 divided by 6 is going to give us 8. That's the job done for the whole of the 3 marks. Okay. Question 25. Diagram shows a solid made from a hemisphere and a cone. The radius of a hemisphere is 4 centimeters. The radius of a base of a cone is 4 centimeters. Calculate the volume of the solid. Give your answer correct to 3 significant figures. So I've jumped onto our formula page here, and we've got half a sphere, semisphere, okay, which we can get by taking a whole sphere and getting rid of the bottom bit. So the volume is what we're interested in. So we're going to want 4/3 pi r cubed as one of our formulas. And the other one that we're going to want is for the cone. Here's the cone shape. And we want the volume again. So the other formula we need for now is 1/3 pi r squared times h. So let's write both of those onto our page. Sphere volume 4/3 pi r cubed. Cone volume like this is 1/3 pi r squared times h. So all we need is the vertical height and the radius for this one, and for the sphere we need the radius. Looks like a circle, but it is a sphere, believe me. So the radius of a hemisphere is 4. The radius of a base of a cone is also 4 because it's shared. Calculate the volume of the solid. Give your answer correct to 3 significant figures. So we're going to be putting it into our calculator and getting a decimal answer. So let's split this into 2 parts. First part, we're going to be doing the semisphere volume. The second part, we're going to be doing the cone volume. Okay, so you can think of it as 2 separate questions. Both of them have a radius r equals 4. And let's go for the semisphere first. So this can be our question 1. This can be our question 2. Question 1 then. Well, if we want the volume of the whole sphere, if we had the extra bit on top, then we would have been doing 4/3 times pi times r cubed, as shown here. However, we only want half of that, so all we have to do is divide our answer by 2. So r is 4, so it's going to be 4/3 times by pi times by 4 cubed and then divide your final answer by 2. So put that into your calculator. 4 over 3 times pi times by 4 cubed divided by 2, and you get, if your calculator does the same as me, 128 over 3 pi. I'm not going to write the decimal out until the end, so I'm going to keep it like that for now. For question 2, we just need the formula 1/3 times pi times r, which is 4 squared times the height. Okay, now we're not given the height directly yet. All we know is the whole way is 14. So what we actually want to do is take away this bit, and then we know what the actual height of this cone is. So stare at that for a second. What do you reckon that length might be? Remember, you're inside a sphere. So anything from the center to the edge is a radius. Okay? It's like a circle, but in 3D. In a circle, it's like spokes on a wheel. In a sphere, imagine a 3D wheel type thing. It's very difficult to draw. Okay. You can draw on as many radii as you want. Okay, so this is going to be 4. So what do we need to make it up to 14? We need 10. So the height is actually 10 here. So times by 10. Put that into your calculator. 1 over 3 times by pi times by 4 squared times by 10. 160 over 3 pi. Do not worry if you're getting decimals. You're going to get the same answer as me in a second. We want to add this volume to this volume. So we want to add these two things together. And you get, regardless of if you do it as a decimal or as a fraction like I have, fractions are just easier to write than decimals. You get 96 pi. Now once it's to 3 significant figures, some questions ask you to leave it in terms of pi. That would be your answer in this case. That's how you do it. However, we want to round to 3 significant figures. 301.59287 is on my calculator screen. 3 significant figures, the first 3 numbers. So we have to look next door to see if we have to round. 5 is going to round it up to 302. Let's not forgive our units. Centimeters, volume, centimeter cubed. 302 centimeter cubed. Clear ink. 26, bit of algebra. It's a simultaneous equations question, but it's not an elimination method. An elimination method is where you have, I don't know, some numbers times x, sometimes y equals x, y equals, and you either add or take away to eliminate a letter. This one doesn't work. Why? Because look, you've got x squared and y squared, and you cannot do x squared take away x. You cannot do y squared take away y. It's not going to cancel anything out. This doesn't work. So we need a method called substitution, which is actually something you're going to use much more if you do A-level maths. If you've got this far in the paper, you might be thinking of A-level maths. So, look at your simplest equation. Which is your simplest equation out of the first 2? The simplest is definitely x equals 2y plus 6. Now the method is called substitution. That means we're going to substitute this into the more difficult equation. Can you see it's telling us that x equals this? So let's write our more difficult equation out. Everywhere we've got x, we need to put 2y add 6 instead. So that is going to change to 2y add 6. Where we had x before, we're substituting for what x is equal to. And this time it's some more algebra. So this is our new equation. And can you see we've managed to eliminate x's? Now here, no more x's. Okay? So it does the same thing as the other method. Now, 2y add 6 all squared is 2y add 6 times 2y add 6. Add y squared is 36. Times this out. If you've got this far in the paper, you must be very good at algebra. So I'll do this as quick as I would normally do it. 2y times 2y, 4y squared. 2y times 6 is 12y. Add another 2y times 6 is another 12y. So that's 24y. 6 times 6, 36. Also because we were running out of space, to be honest. Okay, take away 36 from both sides of the equation. Add this y squared to this y squared to give you 5y squared plus 24y equals 0. Factorize your y. So you get 5y plus 24. It's going to give us some dodgy numbers. So we get, I hope I've done this right, we get that y equals 0, because imagine this is another bracket with just y in. Something times something else gives you 0. So either this bracket could be 0, or, which is what I'm worried about, this bracket equals 0. So 5y plus 24 is 0. We don't get a very nice answer for y here. We get minus 24 from both sides and then divide by 5. I guess it is a calculator paper, so the examiner is within his rights to put this in. Right, now we go back to our easier equation, which is this one, and we substitute again, some more substitution. This time you're putting y as 0 in. So 2 times by 0, add 6. So that's going to be just 6. So that's a pair of answers. Okay, your first pair of answers is y is 0, x is 6. That can actually be written as a coordinate if you like, x first then y, because it represents where these two graphs are crossing. The next one, y is minus 24 over 5. So where you've got y in this equation, you're putting 24 over 5, which is making me doubt a little bit that it might be wrong, but I'm sure my subscribers will give me a shout out if you notice the mistake, and I can write over the video. So 2 times minus 24 over 5, and then add on 6, and you get minus 18 over 5, aka minus 3.6. It's not such a bad number. And if we want to write this as a coordinate for these pairs, then you can put x first and then y. Minus 24 over 5. By the way, if you want to do it as a decimal, it's up to you. Minus 4.8. Right, so that is the tricky algebra one done. You get more marks for these type than for the elimination method. That was 5 marks. And the final question, question 27, shape question. A, B, C, D is a parallelogram. A, B, C, D. Okay. AC is 9. So A to C is 9. As we can see, it's labelled. And that, can you notice, is shared by both triangles. DC is 11, as we can see. So that's 11. Now, because of the properties of parallel lines, and these cutting the same distance, that's also going to be 11. And because of parallel lines again, this is going to be the same as this. Okay, so DA equals CB. Calculate the area of the parallelogram. Now, I'm not seeing this as a parallelogram at the minute. I'll tell you what I'm seeing it as. I'm seeing it as one triangle here and one triangle here. And guess what? The two triangles are identical. One has just been rotated around to get the other one. Okay? So you've got your two triangles put together. Calculate the area of a parallelogram. You could be here for a long time thinking, I've got the base. My teacher's taught me the area of a parallelogram is base times height, so all I need is the height. I think that will work, but it's going to take you longer than what I have planned. I have planned find the area of one of these triangles and times it by 2. So how am I going to do that? Well, there's a formula for the area of a triangle, which is a half AB sine C. I'll show you this on your formula page. And that means that we need 2 lengths and an angle. So here's your formula on the formula page. Half AB sine C. Let's think of your traditional triangle formula. You need the base and you need the height. This formula says, forget base and height. Just give me 2 lengths for triangle and give me the angle in between these 2 lengths. Now, those 2 lengths can be made into a triangle like so. So you need this information, this information, this information, and you can use this formula, which I'll show you how in a minute. For the traditional one, base and the height, 2 bits of information. So this one will work when you do not know the height, which is quite cool. The other formula that we need to look at is the sine rule. So the sine rule says for any triangle, if you label up the corners A, B and C any way round, okay, if you do the angle at each one, sine of the angle, and if you think about how that compares to the length opposite it, it's in the same ratio as sine of this angle and its opposite length, and sine of the other angle and its opposite length. And we call the opposite length to the angle the same letter, just lowercase. So this is what you've got labelled up here. So remember, A and the opposite sine of the opposite angle is the same ratio to B and the opposite angle, and to C and the opposite angle. Okay, so that's the sine rule, which we will also need in this question. So let's think about the area of a triangle formula a bit more. You actually need, let me get the highlighter for this one. You need A and B. So A and B. And you know this diagram here, A, B. And you need the angle in between, C, for you to do sine of. Okay? So if I label it, this was base and height. For the traditional formula, this is A, this is C, should be a lowercase a really for length, this is B. Okay, so let's go back to our page. The sine rule is going to be A over sine A equals B over sine B equals C over sine C. I know it's going to be weird for you to see these 2 different equal signs. That's just representing 6 different equations. This equals this equals this, and this equals this. So 3 different equations, 6 if you put them the other way around. Okay, but we only want one equation at a time from this, and it depends how we label our triangle, where A, B and C are. The other formula that we just looked at is the area of a triangle is a half AB sine C, where A and B are any 2 lengths, and C is the angle in the middle, giving you the triangle. Okay, so let's look at what we've got. We've got this triangle here. We know this is 100 degrees, and we know this length is 9, this length is 11. So from our triangle rule, for the area, we need the two lengths and the angle in the middle. We have the two lengths, but we do not have the angle in the middle. So we either need to find this, or we could find that. Okay? I'd recommend that the easiest way is probably to find the missing angle and go from there. So let's think about what we said about the sine rule and the different ratios. Okay? So sine of 100 is in the same ratio to 11 as 9 is to sine of this angle. Okay? So let's do this in a different triangle so I don't confuse our area one too much. Let's leave that one for now. So let's draw it again. 100, 9, 11, and we want to know, we don't know this length, so we can't yet find this angle, but no worries, because angles in a triangle add up to 180. So if we find this missing one, it's very easy to find the one we actually want. That's a cool little trick. So let's pretend we wanted this one and go from there. So let's label it. Let's say that this 11 is A, and this angle is then going to be A because it's opposite. This length, let's say B, so the opposite angle is going to be B. So we're using this first part of the formula, not the whole thing. We just need one little section of it. Okay, so if you do sine of the angle 100, and A over it, so 11 over it, that equals B, which is 9, over sine of B. Okay? Now, can you see that our unknown in this equation is just B? There is a slightly different way to write this, but I don't want to confuse you because I want to use what's given in your exam. So our job is to get this B on its own, which is quite complicated in itself. So what we need to do is we need to times it by sine B and divide by this. Okay, now 11 over sine of 100 you can put on your calculator. So 11 divided by sine of 100 is going to be 11.169699273. You could store that in your calculator or something. We're going to divide by that and times it by sine B. So sine B equals 9 over what we just said, okay, because we're dividing by this to get rid of it. It's just a number, remember, don't panic too much. To get B out of sine, it's not sine times it, it's sine of it. We need to do the inverse of sine, which is sine to minus 1, okay. So we need to do sine to minus 1 of all this. On your calculator, shift sine. I had it saved as my answer, so that's why I'm doing it a little bit quicker. 53.68292309. So we now know this angle. We actually want this angle here. Okay, so what we can do is we can just say 180 C equals 180 minus 100 minus B. So this angle is 26.31707691. I'm keeping this stored in my calculator. Now we put these numbers into the formula. Doesn't matter which way around A and B are. This might as well be A. This might as well be B. So it's going to be a half times 11 times by 9 times by sine of that angle. Okay, so 0.5 times by 11 times by 9 times by sine. I've still got that saved as my answer. Sine of answer for me equals 21.9 945249119. We read the question, it wants it correct to 3 significant figures. So the answer is going to be 2. Remember we said there's 2 of them. We've just found one of the triangle. 2 times by 21.945249119. Sorry about the mess here on the board. 43.890, etc. 3 significant figures. 43.9 because the 9 rounds the 8 up to 9. So area 43.9 centimetre squared. Difficult question to end it on. 2 tricky formulas. So that would be your grade A star. Anyway, we've completed the paper there. Thank you for watching. I hope it has helped. I found that paper harder than the non-calculator one, that's for sure. So just be a bit careful. Work through at your own pace. Remember, the best way to revise is doing these questions. You have a go at them yourselves with the video paused, then you watch what I do, and hopefully you can really understand what's going on in every question, and it will help you on your journey to get your best grade possible. I sincerely wish you the best of luck with that and with whatever else you choose to do. Thanks for watching. I hope you achieve